Okay, so hi everybody. Welcome to this webinar. Today, BTS Bioengineering is presenting the latest innovation in the field of biomechanical analysis. I am Marta, and today joining us is also engineer Eleonora Puce, who will co-host the webinar with me. Hi everyone. Let's go directly through the main agenda of today. So today we will guide you through the overview of PODIUM system, starting from the concept of functional movement analysis, moving into the system configuration and new hardware and new software, and finally showing practical examples and also practical applications. So now we just do we start with a very brief introduction of functional movement, functional analysis, also with advanced technology. But before starting, we would like to ask you actually, what field do you work in? So maybe just to also for us to better understand your background, to try to also tailor a little bit the discussion on your perspective and move on quickly. So thank you for answering. Okay, so we have the highest percentage in rehabilitation field than sport performance. So it's pretty much like in line also with the podium and system analysis, then a few of research and others. Okay, so thank you for just, of course, the idea of what's your background. So let's move to actually the presentation. So when we look at human movement, we are not just observing something simple or isolated. Every movement is the result of a complex interaction between different systems, the neuromuscular system, biomechanics, coordination, and control. Traditionally, movement has often been analyzed in a fragmented way. For example, we just look at force production, we just look at motion, we just look at muscle activation. In reality, performance and dysfunction always emerge from interaction of these elements. So if we look only at one dimension, we risk missing some critical points, some critical information. And this is why today there is a strong need for integrated analysis, an approach that allows to capture movement from multiple perspectives at the same time and to translate raw data into meaningful insights and meaningful information. To better understand this concept, we can think about movement as something that can be observed through three main dimensions. The first dimension is motion. This includes parameters such as speed, displacement, coordination, and the overall kinematics of the movement. The second one is force. So this tells us how much strength is being produced, how quickly it is developed, and how efficiently it is applied to the ground. The third dimension is muscle activity. This allows to understand how and when muscles are activated, how they coordinate, and whether they are asymmetries or delay also in the activation. Each of these dimensions provide valuable information, but only when they are combined can truly understand what is happening. This is why we often say, as also is written here, one movement, three perspective, and one complete understanding. When we integrate these dimensions, we move from isolated data to complete biomechanical profile. This has a direct impact on several key axes and several key areas, from control to muscle coordination to motion and force, resilience, recovery, performance. With the integration, you can support better decisions, both in training and also in clinical practice. The problem is that today, most movement, actually, and movement analysis tools still look at only one dimension. This creates, of course, a gap in between what we measure and what actually happens in the real movement. And this gap often leads to incomplete assessment, suboptimal training decision, or, of course, some missed information and some missed risk factors. So that's why we want to go through the system that allows for the analysis of all three dimensions of movement, which is PODIUM. We will see PODIUM in every configuration. So the BTS systems, how is it integrated among each other, and also the new hardware and software that actually are the base of the system. So, first of all, PODIUM. PODIUM is an integrated biomechanical solution designed to bridge the gap between laboratory grade analysis and real world usability. PODIUM system is defined as gold standard in sport movement analysis. The main features that make this tool the ideal choice for biomechanical analysis is for example, the possibility to capture ground reaction forces, to perform 3D markerless analysis with AI models, and to synchronize everything in a single software package. Here, we enter the most comprehensive level of assessment, which provides highly accurate and scientifically validated data. PODIUM is a tool that enables a general comprehensive assessment of symmetry and strength in both static and dynamic condition, just in a few minutes. The system is very useful for training, for preventing, for example, potential injuries, and for speeding up the recovery process of athletes, but also in clinical and medical field. In just a few minutes, it is possible actually to collect objective data that can support evaluation, training decisions, and rehabilitation pathways. We make the system particularly powerful is the combination of qualitative and quantitative information at the same time. On one side, you have precise numerical data, so objective data, objective information. On the other side, you have visual feedback that helps both the operator, so the clinician, the physiotherapist, the sport people, but also the patient or the athlete to immediately understand what is happening and to also work and train combined with the biofeedback. This makes PODIUM not only a measurement tool, but also a powerful communication and training instrument. But how actually the system is constituted? So you already know, but PODIUM is constituted of triaxial force platforms, so 3D force platforms, HD color cameras, and new Aura AI HD cameras. These are the new cameras that we are going to talking about today, and we are going to show you now today. So first, the 3D platforms. So the system consists of two or more P6000 triaxial force plates. P6000 force plates measure three components of ground reaction forces, so vertical, anterior, posterior, mediolateral forces, and the coordinates of the center of pressure, as you probably know. HD cameras are usually two and are color cameras. The cameras provides real-time images with superimposed force vectors and 2D joint angles, as you also see, for example, in the picture. The last part is that the system includes an array of 6 or more AI-powered HD color cameras. These are called Aura cameras. Together, these cameras enable a complete 3D markerless reconstruction. So this is the last part that is missing. So you have the 3D force plates, you have the color camera, and now you can also reconstruct the 3D movement through like these new powered cameras. And everything is combined and collected by the software, the same software that that collect all the information of all the hardwares. And of course, PODIUM can also include some other additional tools, such as extra video cameras, electromyography, surface EMGs, that are also naturally integrated in the system. And this tool can be enabled or disabled every time before starting the test acquisition. So it's a scalable system that can actually be personalized or used based on the type of athlete and patient which is in front of you. So now we go through one of the most important part of this presentation, which is the main PODIUM configuration. So one of the key strengths of the system is the flexibility, the scalability. Each configuration is engineered to match the demands of its environment, from routine screening to advanced research. So PODIUM can be of three types. Just the podium, so the classical podium, can be configured, is a 2D configuration. The system uses two cameras and provides real-time visualization of joint angles. This is particularly useful for biofeedback application, where the goal is just to guide the movement and improve motor control. Here in this podium configuration, you only have data, we will show you also later, but you have only data regarding force platforms, so ground reaction forces. In the podium 3D, so the second configuration, we move to a more advanced level. With multiple cameras, the system reconstructs the movement in 3 dimensions. So it allows the full kinematic analysis and saving all the data for post-processing. Finally, you can also have the Podium Lab, which is actually a final laboratory configuration. And here the system can be expanded even further with additional cameras and integration. For example, here you have minimum 8 cameras and 4 platforms, making it suitable for research and high-level biomechanical studies. So this scalability allows the same system to be used across different contexts, different type of movement, and from clinic to high-performance lab. So let's go a little bit more like deep into every stage, every configuration. So this is the first configuration, the Podium Essential Foundation. So here you have two high precision force plates, so two 3D P6000 force platforms with two synchronized 2D video analysis cameras, so just HD color cameras. So this provides the entry point for objective movement assessment and of course biofeedback. So you see 2D joint angles displayed in real time, and you have all the kinetic data. So it's reliable, but it's just the entry level. Here you have the Podium 3D, so the next level. In this case, you have two P6000 force plates, so same like configuration in terms of force plates. You have two HD colored cameras for vectors in superimposed vectors and also real-time biofeedback. Here you also have 6 Aura AI HD cameras, and here through AI algorithms you have the 3D reconstruction of athlete movement in 3D space. So here you not only have just the kinetic data, you also have kinematic data, okay, from these cameras, and you can combine them also to have also inverse dynamics. Finally, you can have the Podium Lab. This is a lab for every movement because it's composed of minimum 8 auxiliary HD cameras, 4 force plates, and 2 HD cameras for the same reconstruction in biofeedback in real time. So this is more specific, for example, if you want a bigger lab in terms of space, but also if you want to analyze like more complex and specific movements, for example, that need like a bigger space in terms of also force platforms. So you can still acquire kinematic data and combine them also to have inverse dynamics, but of course in this case you have more like freedom of space. And this is just a table that actually summarizes what I've just said in terms of differences between Podium 3D, and Podium Lab. So the number of cameras, the number of force plates, and the possibility to add like AI Aura HD cameras. And just for you to have an idea also of in terms of space, we have done also a sort of comparison of the possible configurations in terms of like lab and volume of space, but this is also very personalizable, because if you want, you can also get in touch with us, and we can also try to design the lab and the room as you prefer, and also based on your needs. Okay, the last part of this podium configuration section is the fact that how actually to choose the right configuration. So we just wanted to say that if your focus is just a fast screening, biofeedback, and of course good and very accurate kinetic analysis, kinetic data, Podium is the ideal solution for you. If you need like deeper biomechanical insights, especially with the kinematic, Podium 3D is the right choice. If you need 3D biomechanical insights, kinematics in a bigger space with for more complex movements, Podium Lab is the right choice. Okay, but if you have also questions, you can always reach us and try to understand better what's like the possibility for you. Okay, so let's go through the novelty, the real novelty of this webinar. So the real protagonist of the Podium system actually is the Aura cameras or Aura. I don't know how to pronounce them, but in Italian is Aura. This is the first time that we are showing the new camera to the public, and we are very pleased to announce that the new Aura cameras are now available for the new systems. So what is Aura? Is a full markerless solution powered by artificial intelligence that enables natural movement analysis anywhere from the lab to the field. It has a dedicated onboard AI processor, so Aura is not only a camera, but it's also a small computer that already processes information inside the camera. It uses color-based technology instead of infrared markers. So it enables natural analysis anywhere in clinics, gyms, real-world environments, and it replaces lengthy invasive setups. So it's quick, smaller, lighter, and it gives also the athlete or the patient, the subject, total freedom of movement, and it's also very quick and easy to use. This is a picture of our new camera. And just for you to have also more information. In terms of features, I already said that it's very light and small. It has AI on board and is full HD, and it gets up to 150 Hertz. In terms of also power, that's very important. It gets kinematics and in real time and integrates with the main software for biomechanical analysis. So, for example, OpenSim and PyCGM. And of course, like beside the design is the fact that it has a high degree of technological complexity and is just connected to all the laboratory through just one cable, one single cable. So it's also easy to install and to move. In addition to the new hardware, let's also take a look to the new software for data acquisition and for the analysis. So capturing, tracking, and processing. This software also represents a major innovation in the field of motion analysis. Features a more intuitive interface and new advanced capabilities. So the system features new generation software environment, which is intuitive, guided, and built to accelerate the transition from data acquisition to actionable insights. One of the most advanced features is the analysis software module, so just the module for the processing of the data. Here, the user can actually interact with different visualization tools, such as camera views, marker track like points, body points tracking, and the full skeleton reconstruction with also the muscles. It is also possible to visualize muscle activity and apply biomechanical models, such as, for example, the PyCGM. And this level of detail allows, of course, for very in-depth understanding of movement, making it particularly valuable for advanced users and research application. We will show you also very practically how it works, but just for you to have an idea, this is the main interface. The software has been designed to guide the user through a very simple and intuitive workflow, from calibration to make a capture to make tests. So some specific movement, some specific fixed sport or movement gestures, to also the selection actually of the tools that you need. So everything, as already mentioned, is scalable and everything can be personalized from, for example, video cameras, force plates, EMGs, and also marker-based analysis in the same software. So let's take a little break because I think we have done a lot here. We would like you to ask, what is your biggest challenge in movement analysis? It would be helpful for us, especially to understand better also for the future. For example, what are these challenges, and if there is something that we have already done and we are still doing with these new products and the development of these new products. So we give you a little break, a little time. And then after this part, we move into the more like practical part. Okay, so the first answer is difficulty interpreting data. Then we have lack of objective data. And then we have limited access to advanced tool. Okay. And finally, time constraints. So yeah, the difficulty of data interpretation is something that is real because as companies here we give you systems like validated systems, scientifically published systems, etc. But actually we just give you the system, the tools, and then you have to interpret the data at the end, that the data that come from these tools. But actually I think with the AI systems and the new development of this new technology will get like easier and easier also to get in touch, for example, with other experts, with clinicians, or for example, have also other comparison of studies or or projects that have done the same thing. So it's getting a little bit easier, maybe. But yeah, this is something that we also understand. And actually, in the previous webinar that we have done, there was the same type of answers. But thank you for your answer. We move to the second part, and I leave the stage to Eleonora, who will explain more in detail all the protocols and the features actually that are present in the software.
Hi everyone. So I'm Eleonora and we'll explain a little bit more the protocols available in the system and also the new features of the analysis tool that we can have in the system. Okay, so the system already includes a wide range of protocols covering, say, different type of movements and application. So we have jumping tests such as quantum movement jump, squat jump, drop jump, which are, say, commonly used to assess performance. We have strength and control exercises like squats and hill raises. Then we have some functional tests such as hopping, change of direction, landing tasks. And finally, we also have some postural assessment, which provide information about balance and stability. So as you notice, we have a wide variety of protocols, and this variety allows the system to be used in many different contexts, from performance optimization to rehabilitation. So let's move to the new software features so we can have a look at it. So here I'm about to show you a video of an example of a test performed using the, say, classical PODIUM configuration. In this case specifically, we will see a repeated squat test performed. Okay, so here simply you can choose your configuration, like here, 2 HD cameras and force plates. You simply start the recording. And for example, here in real time, you can check the angles. So visualize the angles that you can see on your right. At the end of the test, the report displays all force related data. Of course, we're talking about 3D forces, so you can see the different components of the forces. And then we can have information also about force distribution and symmetry. And if we click, for example, on the icon on your right, the one with the video, you can always review the video acquisition. This is the simplest configuration of Podium, but for example, if here you add some EMGs, so surface EMG analysis, you can also visualize the data here. And say that good point of this new software is that after you perform the test, you immediately have this result page. So you have your report, and the processing is automatic. So you immediately have the report after that. Okay. What's this? Okay. Okay. So here, this is another video, and this, on the other hand, is an example of acquisition coming from Podium 3D or Podium Lab configuration. In this case, I'm about to show you the video, but in this case, we will use the make a test section, and here we perform a specific functional movement. In this case, we're about to do a counter movement jump test. So as you notice, we are going to click on make a test. We select the test that we want to do. Just by clicking recording, the athlete is guided through the test execution. So yeah, as you can see, once the test is saved, the main parameters are immediately displayed. So in this case, of course, we have the information coming from the platform. So we have some indexes, our force distribution, peak forces, symmetry, also in this case, of course. Okay, so we also have some more complex index that was, of course, also present in the other, the simple body configuration. But here is the plus. So since it's a 3D configuration, we also have the information coming from the 3D reconstruction of the body. So here we can also see the kinematic information. So we have kinematic analysis, and specifically we get to see the angles of the major joints, but also inverse dynamics. So we can see the joint moments and powers. Then, since it's a multifactorial analysis, it's always possible to integrate the surface EMG and visualize its data here. And here, as you notice on the bottom right of the screen, you have a 3D button. This button allows you to visualize the three-dimensional total body reconstruction of the subject that we'll see in the next few slides. Okay. Okay, and now I wanted to show you a little bit more the actual new part of the software. So this is the new features of our software, and this is very helpful in case you don't want to analyze a specific functional movement from the list of available protocols that we give, because it's useful to, do a test and immediately have your results. But you can also perform a total body test. So what you can do is capture any movement in real time, and then using the 3D reconstruction, analyze the data. So that's what we're about to do. So here we click on body, total body. You just simply have to start a test, and you can perform any movement. So any generic movement. We simply have to stop the test. Automatically, a sort of report will be generated. And here we have the 3D reconstruction. So here you can, at first, of course, review your acquisition, and you can review the 3D reconstruction of the body, as you can see. And also, for example, one of the features of the software is that you can match the camera view and with a 3D reconstruction. So your video acquisition with a 3D reconstruction of the body to also appreciate the, say, how good was the reconstruction. Okay. So in order also to explain a little bit more this generic motor gesture analysis, here some more examples of this type of analysis. So here I will show you some examples of three-dimensional reconstruction. These are all generic movement, and you can visualize, of course, different data acquired. For example, if you acquire also the EMG, you can visualize it in this function. You can also see the force, like I'm showing now. So these are the forces, 3D forces during your acquisition. And you can also visualize the EMG, either raw data or in an envelope format. And a cool option of this software is, for example, I don't know if you noticed, but the color of the muscles changes going from red to yellow according to the level of activation. So the higher is the activation of that muscle, the more the color changes from red to yellow. Of course, all these color settings are customizable, but just to give you an idea of some features. And here you can again visualize the forces, right, left, and resultant. So you can either visualize in, yeah, just the view or also see the plot. And of course, you can move around all these plots to also see the corresponding movement and position during the test, during the acquisition. This is just another example. In this case, for example, of course, we have the reconstruction of the body, but we've also reconstructed the ball, for example. So here you not just have the virtual reconstruction of the subject, but also of the ball. Okay. And now the last part is actually a deep exploration of the features of the analysis of our new analysis software. So, of course, always from the 3D screen analysis, you can immediately see the 3D reconstruction of the subject. But of course, we have also some other functions, other features that we'll see together. So at every time, you can always review your acquisition. But in particular, you can, for example, view the trajectory of a specific selected body point. So you just select your point and you can visualize its trajectory during the acquisition. Here, for example, the left shoulder and left hip were selected. Then we just need to run, for example, the acquisition and see the trajectory of these points. Then we can also view the angle. So for example, we can select 3 points and visualize the angle in between these 3 points. So here, for example, we can visualize the angle of the left knee. We can either see, actually, we can both see the variation of the angle during the acquisition, but also visualize the plot. And again, you can move around the plot and see to which point corresponds, say to which position correspond the point on the plot. Okay, then another feature is that we can plot the various body points. So these are, for example, all the body points that you can plot, and you can plot the position, the velocity, and the acceleration of these points. For example, we have selected the knee, the right knee, and we can visualize, for example, this is the acceleration of the right knee during the whole acquisition. And this is the position, for example, of the same point throughout of course, the whole acquisition. Okay, then we can also, of course, plot the triaxial force states once again. We can see left, right, and resultant force. Of course, in the three axis because it's a three-axial force plates. Another feature is also the application of an open scene-based model, and this enables the visualization of the muscles and also its activation. So, of course, if your data contains EMG acquisition, you can visualize the muscles and also its activation. So what I was talking you about before, you can see the level of activation, so the color of the muscle that changes from red to yellow in this case. And of course, you can always plot also the data. So the plot in a row format or envelope if you prefer. Also in this case, you can move around the plot. And lastly, we can apply PyCGM model to calculate joint moments and powers. Probably you already know, but PyCGM is the model and it is a universally used reference model for the for the evaluation of key spatiotemporal parameters. And here, for example, you can view the kinematics. So you can view the angles of hip, knee, or ankle, just as an example, but all main joints. And then you can also view dynamics and inverse dynamics. This is the knee, for example. Then we can move to the inverse dynamics, and you can visualize hip, knee, and ankle. So we have moments and powers, of course, using the information coming from the kinematics and the dynamics. And of course, the force platforms, so the dynamic information. Of course, always in 3 dimensions. Okay, that's more or less it. So this was an overview of the main features of our new analysis software. Of course, you can, as you notice, you can do a lot. We just wanted to show you some features. Okay, this was more or less it. We have time for some questions. So if in case you want to ask some questions, please feel free to ask, and I will leave the stage to Marta for some takeaways and conclusion.
Thank you. So just for conclusion, just to conclude, the take-home messages, the most important take-home messages of this webinar are the fact that Podium integrates triaxial force platforms, markerless 3D motion capture, and intelligent software into just one compact solution. The second take-home message is that Podium can have 3 types of configurations. So from Podium, like classical Podium, to 3D, to Podium Lab. The third important information is the Aura new Aura cameras. So Aura is a AI-powered, color-based, markerless analysis that brings laboratory-grade movement assessment to clinic, gyms, and real-world settings. And finally, the redesigned software transform complex biomechanical measurement into accessible and actionable insights. So it's very important for us, just for you to have this main information. And before moving on, we just would like to ask you the last question, so the last poll. How likely are you to adopt an integrated biomechanical system like PODIUM as part of your daily practice? Thank you for answering. In the meantime, I thank you, all of you, and we have time now for questions and doubts and suggestions and whatever. The main answer, yes, the most likely answer is yes, interested but need more information. Okay, we're here for it. So feel free to contact us also for live demos, other meetings, other live or online demonstration, and also if you want to get in touch also with the sales team for information regarding pricing, etc., feel free to ask us. And the second, most relevant answer was yeah, very likely. So thank you for your trust. Thank you also for your availability. It's time now maybe for some questions, for answering to some questions. So um, I think there's a question by Harry. What is the AI percentage?
That's the asymmetry index. So, for example, I think you refer to the forces. We evaluate right and left force distribution, and you can visualize also the percentage of asymmetry between left and right.
Okay, thank you, Harry. Um, it is possible to have just the markerless kinematic configuration for a cost-effective solution for smaller practices or people that do not want kinetics. So the system at the moment is thought for both kinetic and kinematic. So I mean, the plus is the integration actually of these two dimensions together, plus also the MGs, which is scalable. So we have also other systems just for kinematic markerless analysis and also hybrid solution, so marker-based and markerless together. In this case, like at the moment, this system is just like together with the force plates. So thank you, by the way.
Okay. Danielle is asking, can you get EMG acquisition data from the Podium 2D model or only with more sophisticated models? No, you can get it from also from the 2D model. So from every configuration, you can also always add the surface EMG and get, of course, the data. So yeah, you can.
Again, Harry is also asking, is there ability to generate reports following the analysis you have just taken us through? Yes, as we also showed, we have actually two types, right? So if you have a specific fixed movement upon like the ones that the ones that you saw from the protocols, so counter movement jumps or other type of jumps or other type of movement, you have actually the report like right after the analysis. If you want to do like total body, so general purpose movement, you go through the total body blob. So you from here you go to the new system for analysis, and from here you also get the final report. Yes, we just show you that you have a lot of tools for visualization and, for example, to analyze, to process the data. But at the end, yes, especially if you apply the PyCGM model, you have the final report with all the data included in the movement that you have done. Okay, thank you. Um,
Please compare with
Do
Okay.
you have accuracy? Sorry, Helen is asking, do you have accuracy data to compare with markered? I mean probably marker-based data for normal gait, for example. We actually have done, we are still doing, but we actually have done some studying regarding like validation studies. So for comparison against the gold standard, which is our main gait lab, marker-based gait lab. At the moment, we have an accuracy of 98%, but we have just done about 98, 99%, but we have just done analysis of very fixed movements such as squat jump, counter movement jump. I think we still need to analyze a little bit more also accuracy in general purpose movement. At the moment, of course, it's worthy saying that it's more like for monitoring of, for example, sports gesture like over time. It's very like user friendly, easy, fast because you don't need to put markers. Of course, the gate main like marker-based gate lab is still like the gold standard, especially in the clinical medical field.
Okay.
So we continue.
Yeah. Mhm.
Sorry. Oh,
Okay.
it disappeared.
Yeah. Oh, also, Marcelo was asking kind of the same thing. So we can, if we can, I mean, what's the difference between markerless and marker-based? Marta already explained. Um, Ideally, none, but of course, we're doing some validation studies. And of course, the big advantage is that with the markerless, you don't have to, apply real markers, and you reduce a lot the time of your acquisition. We can show joining also in real time or only after the capture. Actually, you can do it also in real time. We
Mhm.
also have we haven't showed it today, but we have a real time uh, feature option.
Yes.
So yeah, you can visualize in
Yeah,
real
it
time.
was Martin is asking if you can we can show joint angles in real time or only after capture. Actually, you can do both. You can show we can show in real time for biofeedback, but you can also and then after the acquisition, if you have Podium 3D, you have also the kinematics. Okay. Any upper limb protocols? Is asking João Pedro. Olá, João Pedro. Any upper limb protocols? Actually, protocols are personalizable. Can you say something?
Personal, yes.
Personalizable. Yes, you can. We can personalize protocols. So we can. I mean, you can just use the general, the total body general purpose. Tool if you want to have like some any specific movement of your body and you can just select the upper part. That's not a problem. If you want something more like easier or more specific, you can also ask us, or you can still use like the older system, the analyzer, or you can ask us also to create some specific protocols for you. So that's doable.
Yeah.
That's possible. Okay. Thank you for the questions, by the
Yeah.
way. We are
Yeah, if we can get to answer all of you, of course, we'll get to you by email. Let's see. Um,
So Helen is also
yeah.
asking, is asking, we use a foot model. I assume the accuracy for the
Mhm.
foot wouldn't be accurate enough for clinical assessment. Could you use marker data capture from the foot and markerless for the rest of the lower limb? So yes, definitely it's different marker-based assessment, especially for the foot, and markerless are still like not the same thing, but probably like technology is going there at some point. But at the moment, of course, especially for diagnosis, is not the same. We also are working currently, but we already have the hybrid solution. So the possibility to have, for example, markerless analysis plus a marker-based tool, a marker-based stamping that you add in the acquisition. So you have both of them integrated. So yeah, this is possible. Maybe I ask you to contact us directly. So maybe we have a another chat
Mhm.
together to talk a little bit about it. But yes, that's the main point, to try to get to the clinical field, to the medical field with a sort of hybrid solution that can combine both solutions together, because otherwise it gets like slower and more difficult, like to do just marker-based analysis. Okay, thank you for this suggestion and questions. And Alejandra is asking, do you use reflective markers?
No, not for this acquisition. Everything that you saw here is markerless. So the actual reconstruction is done based on the videos acquired by our Aura's camera.
Okay, we have multiple questions.
Martin's asking which is the model used to calculate joint kinematics is pi CGM.
Yeah, which is one of the most used also, for example, from other companies, like internationally and scientifically used, also with other systems. So it's very easy to use it and to apply it also if you have other statistical tools, for example. But we have other questions here. Maybe, I mean, we will definitely answer all your questions by email. We also have your contacts. Let's see if we still have some minutes left. Mm. Do the reports generate verbal summaries, for example, left gastrocnemium firing more than right, or right gluteus maximum is not activating? Verbal summaries, you mean like a sort of
Like the report.
probably like the report
Okay.
that gives you the idea of what's like firing, what's more activated.
Kind of. I mean, if
Mm-hmm.
you use the standard protocols, we've already included this type of information. So, for example, the asymmetry index that was asked before, that gives you an idea. That was for the forces, but does the same thing done on the EMG analysis, for example. Uh, of course, if you do your own analysis using the general purpose test and then you visualize the data, you can get then the data, save it yourself, export it, and but say from the software you can get exactly the percentage of difference between one and the other muscle, for example.
Mm. Yeah, you can also create a
You can
protocol.
create your
Mhm.
own protocol, yes.
Exactly. So you actually get the percentage, for example, if you need them.
Yeah, yeah, of course you have the data, yeah.
Lastly, maybe last question, can the Aura cameras be used on their own to measure 3D gait and running mechanics on treadmill, like a traditional lab setup but markerless? This is always Alejandro. And can the force plates be embedded in the ground like a traditional laboratory setup? Okay, so last question, yes. Usually they are embedded. I mean, it's useful and easier also to get more like ecological movements, right? For example, complex movements. So definitely can be both embedded or if you want also with frames. So it's up to you and the type of lab that you have. At the moment, we don't use just the Aura cameras only for 3D gait analysis or any type of like gait or running, like whatever, because for this type of analysis, we have actually a specific markerless, another markerless system, which is more just for kinematic. This is at the moment very good because you can combine both kinematic and kinetic together. So you also need the force plates. Okay. But we have multiple, like different types of tools that can provide also this information if you want. So you can still get in touch with us if you need also to have more insight. Okay. So I think we are done. We are done for today. I think it's time. Thank you for joining us. And thank you for your questions and for your suggestions. It was very nice to answer and to have this conversation going on. And bye. See
Thank
you next
you.
time.
Bye
Bye bye.
bye.